Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 226. Please turn to it. Page number 226, and today is our lesson number 313. 313. Now listen very carefully. The problem that you see on page number 226, we're not going to do the problem as it appears on the book itself. We're going to change it. We're going to transform it. We're going to metamorphose it into a quantitative comparison question. Quantitative comparison questions, because there aren't too many quantitative comparison questions for you to practice in this new book here, because they're all mixed up together. If you're interested in getting ample practice on quantitative comparison questions, what you can do is, you don't have to actually, if you can find this book, that's great, but in this book that I'm holding here, which is based on the old GRE, but the quantitative comparison questions have not changed. They are still the same questions, same format in the new GRE, the revised GRE. So you can in this book you will find 7 exams. Each exam contains 30 quantitative comparison questions. There are altogether 210 quantitative comparison questions in this book, and you will find solution to every single one of those 210 quantitative comparison questions on my channel. Simply look for this playlist. Just type in quantitative comparison 10th edition. All you have to do is type in quantitative comparison 10th edition, and you will find all of the solutions if you're interested in watching, if you're interested in getting some more practice on the quantitative comparison questions. So what we have done here, we have taken the original problem as it appears on page number 226, and we have changed it into a quantitative comparison question, and this question is going to be very similar to problem number 12 on page number 328 that appeared in this exam on the 10th edition, page 328, number 12. And this is how the problem may appear in the exam. It says twice the sum of the roots of this equation, the equation that you see on page number 226, twice the sum of these roots versus 1. The very first thing we have to do is find the roots. What does root mean? Root means the solutions to the equation. Because it's a quadratic equation, it's going to have 2 roots. For example, if someone says x squared is equal to 9, what are the roots of this equation? In other words, what are the values of x? What are the values of x which will satisfy this equation? And we say we form the questions in plural form because there are 2 roots. It has 2 values. 2 values of x will satisfy this equation. If x squared is equal to 9, that tells us that x could be either plus 3 or minus 3. Negative 3 squared equals 9, and so does positive 3 squared. So this equation has 2 roots. Similarly, this equation has 2 roots, and we have already found the 2 roots yesterday. We solved it yesterday, and we found that the 2 roots of the equations are, as a matter of fact, anyway, instead of simply telling you, just quickly do that. I'm going to do it very quickly. We're going to solve this equation one more time without any explanation, because we already did it yesterday. If you're interested in actually watching the solution, you can watch it in yesterday's video 312. This is how the equation was. The equation is 2x squared minus x minus 6 equals to 0. That tells us that we're looking for two numbers whose product has to be positive 2. You see right here, positive 2 times negative 6. The product needs to be 12, and they have to add up to these 2 numbers that we're looking for. They have to add up to negative 1. Can you think of 2 numbers? Can you think of 2 numbers so that when we multiply them, their product turns out to be negative 12, but when we add them, their sum is negative 1. But since it's 12, it's very simple to figure out what might be. 12 is either going to be 4 and 3, positive 4 and negative 3 that is, or negative 4 and positive 3. In this case, positive 4 and a negative 3, positive 4 and a negative 3 is going to add up to positive 1. Well, we don't want them to add up to positive 1. Right here, the coefficient is negative 1. the coefficient of x here is -1. See right here, 2x squared. This is minus x, which is same as the coefficient of x here is -1. So that does not do the job. The two numbers that we're looking for are these. A -4 and a +3 is going to add up to -1, which is what we need here. So -4 and +3 is what we need here. Watch what happens. So that's it. We're done with this part. Remember, -4 and +3. So we're going to write this as 2x squared minus 4x plus 3x -6. This is where the -4 and the +3 come into it. What do we find in these? This is where I'm going to pick up the speed. What do we find here? Common. 2x is common. Take out, that leaves us with x here, and that leaves us with 2 here. Now we look at these two terms here, this one and this one. We take out 3 common, that leaves us with x and -2. Now what do we find common between this term and this term? What do we find common? What we find common in these two terms is the quantity that we see in the parentheses, this part right here. We're going to take out that common, x minus 2 and 2x plus 3. And that is equal to 0. And since the product of these two numbers, since the product of these two quantities is equal to 0, that tells us that either x is equal to +2 or 2x plus 3 is equal to 0, which tells us that 2x is equal to -3, which tells us that x is equal to -3 over 2. There you go. Those are the two roots. The two roots are +2 and a -3/2. Now we have to solve this. We have to do the solution before we can actually answer this question. The question is, which quantity is bigger? The twice the sum of the roots of this equation, or 1? Which quantity is bigger, or are they equal? So we found the root. The roots are +2 and a -3/2. I need the room, so I have to erase it obviously. So we can do it here actually. So the sum of the roots is going to be +2 plus -3/2. +2 and a -3/2. -3/2 is 1.5. A +2 and a -1.5 is -1/2. Oh, sorry, +1/2. If you have $2 and if you take away $1.50, you're left with half a dollar. So that's the sum of the. This is the sum of the roots. Here they're asking us for the twice the sum of the roots. Twice the sum of the roots is going to be 2 times half. 2 times half equals 1. And what do we have in the second column? In the second column, we also have 1. It turns out that twice the sum of the roots is same as the quantity that we given in the second column. Therefore, the answer here is C. Now let me tell you, if this problem does appear in the exam, now I shouldn't say if this problem appears in the exam, if it actually does appear on your exam, if you see something like this in the exam that you take, that is actually a very good sign. It's a very good sign because the new GRE, now I'm breaking into a sermon here, as opposed to the old GRE, which used to be paper and pencil format, as you know, the new GRE is computerized and is adaptive. It's adaptive meaning that it adapts based on the ability of the person taking the exam. So they start you out. Where do they start you out? How does the computer start you out? Think of these. I want you to pretend, I want you to imagine that as you're sitting at the desk there, I want you to pretend that in front of you what you see are 3 barrels, and they are marked easy, medium and hard. And what the computer does is he puts his hand in one of the barrels and he picks one question at random. The question is, where does he start you out from? The computer, to begin with, he assumes that you are neither a dummy nor a genius. So he starts you out with a medium question. So he gives you first medium question. If you get it right, he gives you another medium question, he gets you right. Gives you third medium question, you get it right. He graduates you to the hard questions. And then he gives you a hard question, and if you get the hard question wrong, he demotes you back to the medium question. He gives you a couple of more medium questions. If you get them right, he graduates you back to the hard questions. And if you get one hard question right, he gives you the next hard question, he gives you third hard questions. In other words, all questions are not created equally. Back in the old days, all questions carry the same weight. They all give you 1 point. When you get one question right, or 10 points actually, They were all worth the same. That is no longer the case here. The harder questions are worth more money. Think of this in exchange rate is not 1-to-1. Easy, medium, and hard. The exchange rate is not 1-to-1. You get more credit if you get a hard question right. So if you happen to see a question of this level, of this caliber on your exam, that is actually a very good sign. That is a very good sign, which means that you have graduated to hard barrel. That's it. If you keep seeing one question after another and they are all very straightforward and very simple, that is in fact actually very bad sign, because you must have blown a whole bunch of medium questions and the computer has decided that all you can handle are the easy questions. So there are two people sitting next to each other. One person does X number of questions, another person does the X number of questions. They have done same number of questions right, but that does not mean they're going to get the same score, because maybe person A, most of the questions that he did were all easy ones, and person B, most of his questions were hard ones. Well, because he did most of the questions hard questions, his score is going to be higher. You understand? Anyway, that was a little bit of a sermon here, but this is considered a fairly difficult question here. One more time, here's how the question goes. So they give you the equation here: 2x squared minus x minus 6 right here. 2x squared minus x minus 6 is equal to 0. And your job is to first of all find the roots of this equation very quickly. You can't take forever and ever. This process that we did here should take just few seconds. Once you find the two roots, we are still not done yet. Then you have to find the sum of the roots. The sum of the roots here, and sum of positive 2 and a negative 3/2 is positive 1/2. We're still not done yet. Then we have to figure out twice the sum. Twice the sum is going to be 2 times half, because the sum was half. Twice the sum equals 1. Then we look at what is given in the second column. Second column, they also give us 1, therefore the two quantities are equal. The answer is C. That's all. Now what I'm going to do tomorrow, in the next video, what I'm going to do tomorrow is actually the problem that you see, question number 12 on page number 328, page 328 of the 10th edition of the revised 10th edition of the old GRE. What I want you to do in the meantime, is to type in this tag, just type in quantity comparison question 10th edition and put in, let's see what day it was, if I made a note here or not. Just give me 1 second, perhaps I made a note here. Then if I did, that would actually help you out. That will find very quickly here. Oh, what do you know? Day number 129. Day 129. And in that question, it says, same exact question. No, nothing has changed. Here's how the question says. It says, twice the sum of the roots of x squared minus 3x plus 2 equals to 0. We have to find the roots of this equation. We have to take the sum of the two, then we have to multiply it by 2, because we were looking for twice the sum of the roots, and then I want you to compare it against 6, quantity 6. Now what I want you to do is this thing, two things. First of all, I want you to solve this equation, solve this problem yourself. Solve this problem yourself. Once you have solved it, then you can go and watch the original solution, which is what you're going to find on day number 129. Just type in quantity comparison, 10th edition, or you don't even have to type 10th edition, just type in quantity comparison, day 129, it will pop right up. And if you ever have trouble finding anything, then the next best thing is to also type in my name with it. Quantity comparison, day 129, Keshwani, and it will pop right up. But first, I want you to do it yourself, and then compare your work against the original solution that I did on day number 129 many moons ago. Alright, bye now.